This is the Amp Hour Podcast, recorded August 1st, 2011. Episode 54, Embedded, Elchee, Epexegesis.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Chris Gamble's Analog Life.
And I'm Jack Ganssle with myself.
All right.
Hey, Jack. Jack Ganssle's in the house, everyone. Welcome, Jack.
Well, Thank you. I appreciate it. I really am looking forward to this. I've been following the Amp Hour for quite a while.
Oh,
that's
awesome.
right. You were like one of our first benefactors in the media. You wrote about us early. I believe you called me a young whippersnapper or something like that.
Whippersnapper,
I think
yes.
so. I did, and since I'm a certified old fart, sometimes the audio and video stuff I stay more away from. I tend to go more towards the written word because I find I can consume something written much faster than I can by watching a video or whatever. But hey, this sounds like fun.
Yep.
Well, there goes Dave's model.
Yeah, exactly. My business model's right out the window. All this talk about old fart and young whippersnapper, geez, it sounds like you're Australian.
Are those? I don't think those are Australian sayings, Dave. I got to say.
Oh,
no bloody way,
okay.
Dave.
Interesting. Hang on. I think I've got this stupid, because we're using Skype. Oh, no, we're using Skype, and my audio meter's peaking here. Sorry about that. But I may have
sure
clipped.
You sound fine. Yeah, you sound fine to us. So
all right,
good old-fashioned audio
had
problems. We're back. We're back to our normal level of Chris mess-uppery here. So
normal level of incompetence. Yeah.
Well,
Jack
I'm
has been
still
very
warming
kind.
up the vacuum tubes here, guys.
That warm, crunchy sound that all those audiophiles love.
Yeah,
Jack,
right.
Right. With their $10,000 speaker cables.
Yeah, exactly. For a digital signal.
That's right.
Yeah.
Gold-plated. It's important.
Right.
So, Jack, tell us about your background.
Yeah.
Oh, well, I mean, I've been in the
For those who
embedded
don't know.
field forever. Go ahead.
Forever, huh?
Well, just about. I guess, the 4004, the first micro, came out in 1971, and the 8008 was the first 8-bitter, which came out a year later, and roughly at that time is when I got into embedded systems. So it's been a
pretty
long
early.
time.
Yep.
Yeah, it's really a great field, and I was very fortunate in that I was able to get a job as an electronics tech when I was 16, and it turns out that the company where I was working decided to get into microprocessors with the 8008, but it turns out no one knew anything about digital design or software, so I got sort of bumped into engineering while I was in college, which was not good for my college career, but was great for everything else.
Right.
Yeah, well, that seems to be a common theme. We read about like Jim Williams, who sadly just passed away, and he never finished MIT. Our friend Jeri, you know Jeri.
Yep.
She never finished high school, I think, and she's rocking the electronics world. I mean, there's tons of stories like that, and it's just because it's hands-on and you get to know it. Like that. I don't know if you finished a degree or not, but it doesn't really seem to matter.
Well, actually, I went through 4 years of double E, and when I was 3 courses short of finishing, I stopped. I was so busy working and having so much time building these systems, so much fun building these systems, that I just couldn't get around to finishing school. And, I have a lot of regrets. It was really a dumb move. But I think partly it's been good for my career because I've stayed away from having real jobs because I figured no one would hire me. So.
Oh, yeah. Well, how do you define real jobs then? That's interesting.
Well, I did have a real job at that company where I was working as an engineer building these systems, but I think it was 1980, I quit there and started a consulting outfit with a friend, and we did that for a while. Then I started a company that we manufactured in-circuit emulators, designed and built them, and did that for like 15 years. And then around the mid-'90s, sold that company. I tried retiring for a day and was bored to tears. So I started doing what I'm doing now.
Yeah.
Wow, that's awesome.
Yeah, it's a lot of, this is a fantastic field. It's so big that you can do pretty much anything you want to.
Yeah, I have to agree. It is. It gives you a clean slate every time you start, really, you can do, as you said, pretty much anything. It really is quite amazing. And it's amazing how it's actually progressed from those days of like the 8008. Sorry, was it, the 8008 you started with?
Yeah, sure was.
Wow,
which was this, it's a miserable little chip. I mean, it was...
Yeah, I know. I was going to say they were so massively limiting back then. But well, that's compared to today, right, with hindsight. But I guess back then they were the world's most amazing devices, right?
Embedded systems is such a big field, and if you listen to the press, and of course I write for magazines, so it's sort of hypocritical.
You are the press.
but if you read the magazines, if you're not doing 32 bits at 500 megahertz, you're some sort of dinosaur. And the truth is, Microchip sells 1 billion of those brain-dead little picks, which are wonderful parts. They're really, truly wonderful parts. But they're really pretty minimal parts, and they sell 1 billion a year. I mean, I see so many applications which are just literally hundreds of words of memory is the entire app. Because,
absolutely. I've written them myself.
Yeah.
And everyone always says that is the death of the 8-bit micro. They've been saying it for 20 years, and it's just rubbish. It's horses
not
for horses,
No, it's not going to happen. I mean, I've been hearing it forever. And, it's kind of interesting. You can get a high integration ARM part, like from ST, for 65 cents. And so there you got a whole computer for 65 cents. You'd think 8 bits would be dead. Well, I think the converse is true. I think what that means is that 8 bits will become even cheaper. And so whole new kinds of applications you never would have dreamed of will surface. Right. They'll be like smart dust. There'll be Johnny Appleseed out there casting sensors into the wind, and there'll be self-assembling mesh networks coming together. I mean, I think it is, whether you're doing 8 bits or 32, this is exciting stuff. And in a way,
it doesn't matter. Yeah.
The low end is in some cases even cooler than the high end. The high end can be so big and complicated, and you got these gigantic teams doing all this work and stuff.
Yep. And
you kind of get lost in the crowd. Whereas on the smaller end, you can be the hardware designer and the software guy and technical support and the whole 9 yards,
Exactly.
You don't have a choice about the technical support, right?
You don't have a choice.
Yeah. And with those 32-bit micros, therein lies a trap for young players, right? You might be able to buy it for your 60 cents or whatever, but then often they will need, you need a 1.2 volt core voltage or something. Bingo, you've got to add an extra regulator for that. You can't just run it from your 3.3 supply or straight from your battery or something like that. So it increases your system cost, and other complexity issues come into it. And, it's not just all about the price per part. But, but as always, you pay per square area of silicon. Ultimately, that's what it comes down to. An 8-bit will always be a smaller, for all things the same. 8-bit will always be cheaper than 32-bit.
And it's even bigger than that, I think, Dave, because there's things like, you really put your finger on it, like with power management. If I see a lot of 8-bit applications where the processor requires so little power. The problem isn't that it's going to suck the battery dry. The problem is that the battery itself discharges after 20 years.
Yeah, that's right.
And for a lot of applications, that's huge. I mean, it's huge.
I know. It's massive.
Yeah, or energy harvesting. I mean, there's a lot of ways of getting free power where we'll never get more than microamps or even nanoamps.
Yeah, nanoamps. Microamps is huge in the energy harvesting business.
But that really opens up a lot of opportunities. And, I think the 32-bit world is way cool. But 8 and 16, man, there's some cool stuff going on. And I think it's going to continue to be really a great area.
So there you go. You heard it from the expert himself. The death of the 8-bit micro is greatly exaggerated.
Greatly. I had a conversation 15 years ago over dinner with a well-known industry analyst, shall we say, who
shall remain nameless here?
Remain nameless. And he told me that what drives the computer field, and this is an embedded guy, but what has always driven the computer field is pornography. And that what the porn vendors want is the highest end processor that they can possibly get to push their content. And sure, okay, that might be true. And so he went from there to say clearly that the low end processors are going to go away. Well, I mean, I could be wrong, but I don't think any 8-bitters have ever been, delivering porn content.
Maybe back in the days when they were really hard up for material. Huh?
You're right, exactly. Yeah,
that's funny.
There's all different kinds of markets in this business, and a lot of folks tend to just focus on limited ones like datacom and infotainment and stuff like that, because that's where all the to go back to this, make an analogy, that's where the sex appeal is.
Yeah. Right. Well, the interesting field
and
of the new mobile phones and the apps and things like that, a lot of stuff, everyone talked about, everything's going onto the cloud, everything's going onto the internet. But with phones, everything seems to be going back to apps and doing it locally because we don't have the bandwidth yet. There's lots of talk about that and how a lot of people don't want to access the internet because the apps, all they want to do is run these apps and things like that. It's a mobile computer instead of, and there's all sorts of, people, booms and bust things happening in various aspects of the embedded community. One thing I wanted to get your opinion on, Jack, was this, the soft market, the soft processor industry. Now, like 5, maybe 10 years ago, right? That was all the rage. Everyone said the soft processor market is the future, right? All hard micros will die, right? Because everyone will be using FPGAs. And what happened there? Well, we've now switched back where all the FPGAs are starting to get hard processors in them because the concept just didn't really work except in the more niche applications.
Well, it's very interesting.
What's your
opinion? I think that the soft processor thing, and like you say, they're moving towards a hard, like Xilinx now is that new core with the hard part on it.
The ARM cores in them,
I think that it's a fantastic way to build some classes of systems, but FPGAs will always cost a lot of money. It's just the nature of the component.
It's that square area, right? That square area of silicon trap.
Well, what you're doing is you're making a trade-off. Everything in engineering is a trade-off. And with an FPGA, the trade-off you're making is reconfigurability versus dollars. And for a lot of apps, man, that is a way to go. But you're not going to get down to a 20-cent processor doing that.
No. So, you can get a $1 FPGA these days, but they're not very big.
You probably put a processor in there, though.
And the other processor problem is you drop a processor in it and you start to, suck away at, most of the resources of the FPGA, and then you don't have anything left to do what you want to do.
And I mean, it's not very power efficient either, right?
No, man, those things are hot. They run hot.
Yeah.
I mean, I see FPGAs, the high-end stuff. I mean, you've got to basically feed liquid nitrogen into them. And, I mean, some of them will cost $15-20 per chip.
Yep.
Like I've used ones that cost a couple of grand, and you're soldering those suckers into your prototype, and you're, shit, I better not screw this up.
Oh yeah. But I mean, it does bring a lot of interesting stuff to it. And when I first started doing FPGA design, I thought that this was all going to be the future. But then you start to look at where things, the trade-offs.
Exactly.
And it just, it's perfect for some things and not perfect for others. But it does sort of illustrate, I think, another trend that we're seeing in the FPGA world is that hardware design is moving towards software. Now that everyone's using VHDL and Verilog and System C and all that stuff, the hardware folks are more like software people today, except they've inherited all the evil of software, but they haven't learned stuff like configuration management and all the stuff that the software community has learned so painfully over the last 50 years.
So it's starting to bite them in the rear kind of thing.
Yeah, it is. But I do think we'll see more of it. We're going to see a lot more of this merging of the two because, I mean, there are a lot of obvious reasons. And then there's the cool things like, I don't know if you've seen some of the Altera tools. You can, you write your C code for their NIOS processor, and they can highlight some of the code and say, design that into hardware.
The hardware compilers are pretty cool,
Yeah,
there's two versions of that, too, isn't there? Isn't there one that also does it as an instruction if you're using the NIOS as a processor?
Right.
And so it does an instruction as opposed to just block of logic, right?
Right. So it's a very interesting sort of change in the way that the hardware and software has traditionally been on different sides of the fence, and those two things are truly merging in many ways. I think we're going to see a whole lot more of it. Hey, if we beat up on FPGAs because they're big and stuff, but the truth is transistors are pretty close to free, and so FPGAs will follow the usual trend. It's just they will always lag, by their nature.
Well, I've got an item here. I was actually just yesterday, I was laying out one of the smallest FPGAs you can get. It's a 36-pin chip scale package. It's an Actel Igloo Nano part.
Okay.
I'm not sure how many gates, I forget. But the package itself is the same size as the footprint of the two 0603 bypass capacitors that the chip needs. Right?
Good Lord.
It's like something seriously wrong with the world when your bypass capacitors are bigger than your chip.
Who would have thought? And a capacitor has got some physical limitations. There's a limit to what you can do to make it smaller.
Granted, I could have used 0201. Or, but it didn't warrant that, right? This was a prototype thing, so
right.
Damn it! If I'm forced to use this bastard of a package, then at least I'm going to put in some capacitors I can solder, right?
But it goes back to our earlier discussion. You get to a little tiny nanoamp circuit, you don't need that bypass cap.
Yeah, well, exactly.
Save some money.
So I could actually leave it off, and that's what this thing is. This thing's working on the smell of the proverbial oily rag, so I probably ultimately don't need that bypass cap. But it is working at about 2 megahertz, though, so that's getting up there. It's not like it's... Yeah, I don't know. Anyway, I did put 2 bypass caps on just as a good measure.
Well, 2 megahertz, you're really pushing the edge there, Dave.
Yeah, I know. It's bleeding edge stuff. Oh, boy. And here's another annoying thing, right? The Actel Igloos, here's rant time. Rant of the week.
Okay.
Do we have any music for that, Chris?
Dave, we haven't had music for a while.
Right,
okay.
Sorry,
buddy.
Fail. Anyway, do we even have a segment called Rant of the Week? I think we used to, didn't we?
No, we don't.
Oh, there we go. Okay, new segment. Being the professional radio show
Jack,
that
just
we
so
are.
Dave makes up segments as he goes along.
Yeah.
See, this is sort of like agile development.
Yeah.
Wake word of the week, agile development. Oh, boy. Anyway... These Actel Igloo parts, right, they famously claim one of their big key performance things is that the core voltage can work down to 1.2 volts. Mm-hmm. Fantastic. So you're designing your 1.2 volt core power supply and you use it at that. And then if you didn't read the fine print, the little asterisk that says, oh, by the way, the core actually needs 1.5 volts for programming. Otherwise, you can't program the damn thing. Right? You've got to be kidding me.
Oh, that's great.
Unbelievable. So what they do on the in-circuit programmer, they actually have a special output pin which is designed to drive a MOSFET, which you are supposed to build into your design so that you can switch the core voltage just for programming. It's like, what a waste.
Give me a break.
Come on. I know. That is... I reckon somebody screwed up there. I reckon marketing got hold of that. Because I think these things used to work at 1.5 volts, right? And then they realised, they tweaked the manufacturing process. Oh, I think we can now use it at 1.2 volts. Great. Let's market that. And then they...
I don't know, Dave. I'm not going to give them too much hell because, 1.2 volts, the difference between a 1 and a 0 is starting to become, pretty close to noise levels.
It is down in the noise. I've got to admit, it's very impressive, but really, that's just annoying. That is bloody annoying. I've got to tell you. Anyway, I was a bit miffed. So
I can tell.
End rant. Okay.
If Dave knows one thing, it's when he's miffed.
Yeah.
You have
and
to be in
not,
touch with
and
your
I
inner
know.
myth.
Please don't write in. It's not Actel. It's bloody micro semi now that every company's buying every other company. And give me a break.
Yeah.
Jack, how about that? I mean, what's your take on the industry in general? With there's a lot of mergers happening. It seems like, and what's your take on that and a lot of the acquisitions?
Well, we're kind of now victims of our own success. I mean, the cost to build a fab has gotten so high that there aren't very many people who can afford to do it anymore. So you have a couple of things happening. We see the industry mergers, of course, and we see the growth of these fab companies, like TSMC and all of that. And I think we're going to see much more of it because the cost of building a part is getting higher. But there's a part of me that sometimes wonders, if we really need, for many applications, all this high-end stuff. I mean, I sometimes wonder if some little company in the Ukraine is going to take one of these old 500 nanometer fabs and realize they could build some way cool parts because the fab is entirely depreciated. The process variance issues aren't significant. So they can do a really sloppy job and knock out some major cool chips doing that.
Okay, so I guess you have to weigh in on our continuing debate here at the Amp Hour.
Well, first,
no,
Chris.
You're not going to raise.
Oh yeah, that's what I was going to do.
Oh, come on.
Okay.
Jack, do you know what I'm talking about here?
No, I don't.
Okay, so the wager going. So the wager going right now is that if I'm right, and I think it was 20 years, Dave, is that right?
Well, no. Well, you added that stipulation later. But basically, back in the first episode, Jack, I think it was one of our first episodes, Chris claimed that you would get a chip-making machine that you could have at home that will just magically spit out chips just like the MakerBots, those 3D printers print out things, right? He reckons that you would have this chip-making machine and it would be a revolution. Quote marks. And, everyone would be making their own chips at home. And I instantly, straight off the cuff, called bullshit. And Chris has been trying to back out of it ever since. So
I have not been trying to back out of it. Right now,
Wait a second, guys. They already did it. It's called an FPGA.
Yeah, exactly. That was my argument. One of my arguments. One of my very well thought out arguments.
Yeah. Oh, yeah, very well thought out.
Oh, come on. How do you test the thing? How do you package the thing? How do you compete against DigiKey with 100,000 parts?
I don't think there's the issues. I don't think there's any demand for anything like that. I don't think that it brings any advantages to anyone, even if you're just doing it for a hobbyist standpoint. It's so much easier to either use an FPGA or wire something up yourself or whatever than to get involved in building a chip. I just don't see brings a lot to the table.
Thank you very much, Jack.
Sorry, Chris.
Now, I just have to say, what does Jack Ganssle know about the electronics industry? Right. I'm just going to say it right here.
Right.
Well, I'll tell you something, Chris.
This is my litmus test.
See, Jack just did that straight off the bat. He had no clue what that is, and it just hit him, and he knew that it was bullshit. See?
I agree with you.
Just like me.
Yep. That's sorry, Chris, but I'm sure
sorry,
you can win
Chris,
on another issue.
You've been thinking about it too hard. Yep.
Well, I guess I have more people to prove wrong then. Oh, well.
Excellent. Well, and the debate continues.
You're getting married in the fall, right? So then
That's
you
right.
can enter a whole new debate. Now, I have to admit, there are some significant upsides. My lovely wife just brought me a martini. So how bad can things be?
Drinking and radioing, that's good. That's awesome.
The next 40 minutes could be a good one, folks.
That's right.
Stay tuned.
I hope we're not recording.
So,
how do you detune a podcast?
Detune?
You can't.
Detune?
Like, you can't, everyone, stay tuned, it's not like you can just tweak, it's not, I guess you can hit the stop button, right? But you can't just tweak the dial and tune to another podcast.
I assume you're going to edit all this out, right, Chris?
We'll see, Jack. We'll see. So, speaking of martinis and relaxation, you and I were talking before the show about your priorities, and I was really impressed by that. And so you said that you make a priority to get out of the office a little bit of the year. Can you tell us about your philosophy there?
Well, I feel very strongly about this. I think that especially Americans work way too hard, and I'm guilty of that myself, even today. But I was really struck by a Lee Iacocca quote. He said, "No one on their deathbed ever says, 'Geez, I wish I had one more hour to work.'" And
Yeah.
I really believe that. I said when I started doing what I'm doing now, I set a goal for myself to take 4 months vacation a year. Because
4 months, wow.
Yeah, and I haven't been able to live up to it recently, but because my family is important to me, especially when my kids were little, I wanted to be able to spend a lot of time with them, and my hobbies are important to me, and life is important to me, and as much as electronics is great, you have to be more well-rounded, and there's so much to enjoy in life that I basically set a goal for myself that vacation is crucial. And 4 months has not worked out real well, but we probably average between 2 to 3 months a year. And
that's awesome.
You got to keep a smile on your face. A very wise guy told me. He said, there's two things you need. You have to make money, and you have to have fun. Either one by itself is not enough.
Yep. Couldn't agree more. I've never worked on my birthday. I have this one, doesn't matter what was on. I've never worked on my birthday in my entire life. I always take the day off. Yep, it's one of my things. And now I work from home. Well, it's so much better.
No one knows what you're doing. Right. Working from home is the best. So do I. It's fantastic. We get up in the morning, shuffle across the hall. And here, my wife works with me. She takes care of all my travel and all that kind of stuff. It's a very, very civilized. And to go back to philosophy, I guess what I'm saying is, I sat down and decided to design everything around my life rather than design everything around work. Sort of re-engineer the whole trade-off. And it took some experimenting and playing and stuff, but I'm pretty pleased with the trade-off.
Yeah, that's good. So for the balance perspective, I'm guessing you had a little bit less of that because you just got back from India, so you probably had to work a little bit more while you're over there. Can you tell us about that?
Well, I was over at the Embedded Systems Conference in India, and I guess this is sort of a two-part thing. That the Embedded Systems Conference India is phenomenal. It's just fantastic. There were about, I think they told me 400 attendees, so it's very small compared to the ESCs in the U.S. But I've been to a number of the ESCs in India, and it always blows me away. I'm seeing the future when I see these engineers who are all very young, all very eager. They've got these glint in their eyes. They're so engaged with this feel and excited about it. Yeah.
That's great.
And I don't see that as much in many of the other places I go. I just, there are a lot of problems in India. There's, education issues still there and everything else. But I see a new generation that is desperate to make this work. And I talk to a lot of engineers here in the U.S. who will say, but those Indians, they're not as creative, or they're not this, they're not that. Well, maybe, but, these are smart people.
Some of them are going to be.
They're going to figure it out. They're going to figure it out.
10 years, 5 years, 2 years.
They have so much to gain, whereas, and not to knock, every time I travel overseas a lot. And I've been doing this almost for 40 years, and every time I come back to the United States, I'm happy to come back. It's a great place. But sometimes we're a little fat, dumb, and happy over here. And for many people, the expectations are that at a minimum, you will own a house, 2 cars, yada, yada, yada. Whereas a place like India, and it's not the only place I see this, the fact that you can actually move out of your parents' house and all that is something to aspire to. It's incredible. So
it seems like my generation is trying to do the opposite. Trying to move back home.
Stay at home as long as humanly possible.
And maybe it's just shifting back towards that way, where if economics and hard to find jobs for recent grads in the U.S., then, maybe it'll go that way, and then those kids will be hungry, and
there's no
the
such
cycle
thing
begins anew.
There's no such thing as balance. There's no stasis. Things are always shifting to accommodate changes in the environment. It's like natural selection. Nothing stays still, and that's certainly true here. I sometimes worry that we have been through a sort of a Camelot, like a golden age since sort of the end of World War II, where everything was just wonderful for folks here. And things are getting harder now.
Downturns, I've heard, but
there were. But generally, though, the quality of life, has skyrocketed. Freedom and all that sort of stuff, and
people of the middle class haven't been starving,
and all that sort of stuff, and
I mean, it's been wonderful. It's been, the U.S. has done incredible things as a result of all this, but I worry for the sake of, say, my kids. And others, what things will be like. So then the other side of India, because you're asking about India, is India itself. Have you guys ever been there?
I have not. No.
Fascinating place.
What cities are we talking about here?
Well, Bangalore is one of the big centers of electronics, and it's just the more I go to India, the less I understand it. The culture is so different, and really religion is woven into the culture in ways that, much as I try to understand, I don't. The poverty is grinding, just grinding. But then you see tons of billboards with signs like "Learn English," or "Improve your English," because these people want jobs in call centers. Or I was really struck by a couple of signs I saw this last trip. Need to gain weight? We can help.
Oh, wow.
I'm so confused. My American brain is screaming.
The Embedded Systems Conference starts off with a candle lighting ceremony.
Wow.
And I'm trying to figure out what the meaning is. It's a beautiful thing. I don't understand it at all. But our cultures are very not really orthogonal, but they're definitely not aligned, and it's quite fascinating.
I'm surprised it was only you said 400 people total?
I think, I'm pretty sure it was 400. Yeah, it's tiny.
But it's fairly expensive to go to, right? So I assume that's a limiting factor.
I think almost everyone who attended was their companies paid for it.
Oh,
okay.
right, yeah.
But it's a fraction of the cost of the U.S. In the U.S., to go to the conference sessions can cost you a couple of grand, and I think in India it's about a tenth that.
Wow. Whew, that is crazy.
Yeah, it's interesting, but all the big guys were there. Wind River had a booth, Green Hills had a booth. Even though the turnout is slow or is low, what I'm told is that the quality of the attendees is very high.
Yeah,
and some of the talks were pretty advanced. I mean, there was a whole day session on Android. I sat in for some of it, and boy, I'll tell you, that was a fast-paced session, and people were taking notes like crazy. So. There's cutting-edge stuff going on.
Yeah. And so do you think they're keen because they're hungry? No, even in the true sense of the word. Hungry.
I think the engineers are not hungry that way. The engineers, anyone who's an engineer is rich by Indian standards.
Right, okay.
But they are hungry to learn. But, man, you can see that. They are hungry to learn. And the truth is, I see that at all the ESCs. The people who are willing to cough up the money for the conference program are, by and large, anxious to learn. I think I see more of a desperation is a wrong word. More of an unfailing commitment to it in India than I do, say, at the ESC United States.
One problem with India, though, is their class-based system, I am led to believe, so that it's not as easy for, someone who's less fortunate to rise up and make it, really, which is really unfair. It's tough.
I don't know. I don't understand that enough. I've been trying to. However, if you read the personal ads in the local paper for boy wants girl, it's never girl wants boy. Boy wants girl.
That's a world constant, right?
Yes. The required cast is always listed.
Yes.
So
that's
true.
Thanks for an awkward Craigslist ad, huh?
Yeah.
I guess so.
Yeah.
Wow. I wonder if that same class system exists in hiring. Oh, well, I'm sure it does, but in terms of hiring engineers and things like that. Are you even able to go to university if you're one of the lowest class people, even if you can afford it? I mean, I don't know. Any viewers from India can clue us in on that?
That would be
listeners. Sorry,
I would love to hear that because I'm very interested in understanding the culture more. I have no sense of that at all.
Yeah. Well, Dave, or not Dave. Sorry,
whoever you are.
Just talk. Yeah. Other guy over there. So Jack, so where else? I'm interested just from the education standpoint too. So obviously there's a lot of up and coming engineers in India, and just kind of what you've seen there, and also what you've seen because you travel so much. So other parts of Asia, up and coming engineers. What's your general feeling about education overseas and other job markets overseas?
I think historically, the education in the Western countries. Well, okay, let me back up. I'll complete my sentence. Historically, the education in the Western countries has been significantly better than in the Asian countries. And I'll give you an example. I often flash up a slide of Faraday's law, which is that awful, nasty thing from electromagnetics that freaking killed us all, And I purposely change, this basically relates E, the electric field, to B, the magnetic field. And I change the E to B. So B is on the left and right-hand side of the equation. In the United States, not once has anyone ever called me out saying, that's wrong. In Germany, every single time, somebody will stand up and say, that is wrong.
Jack's best German accent.
I think there is a difference even in the Western cultures on the focus on this stuff. What I'm finding in Asia is that there's, I think it's more practical, learn C in 15 minutes or whatever it might be, with less of the theoretical basis that we see over here. And my observation is that in many of the Asian countries, and it's not fair to say all, I'm not even sure if India would be called Asian or not. Certainly this is not true in Asia. But in many of the Asian countries like Malaysia, Singapore, even in China in some ways, if you're an engineer in 10 years, you're a failure. Engineering is a step to management.
That's right. If you're still an engineer, you're doing it wrong.
Yeah.
Got it.
And so what that means is that engineering is sort of like secretarial school. You have to go through this in order to get a real job.
Yeah.
Boo.
So how does that affect actual technical expertise then? I mean, does it just kind of fall away after that point? I mean, is that what's limiting not the creativity but maybe the absolute prowess? Because they have PhDs over there and everything, but are those PhDs going into management as well, or where does that knowledge go?
They say that after 10,000 hours of deliberate practice, you become an expert, and I'm not sure how you measure that in terms of a 2,000-hour work year. That's 5 years of experience. Let's assume you're running 50% efficiency. That puts you at 10 years experience. That sort of suggests that when you reach the peak of your competence, then you move off to some, into management or something. And that's not a bad thing, because you don't have to be a senior engineer to be a hugely important part of the team and very productive.
Right.
And these places, this is all very new. They're still trying to figure things out there because, outsourcing didn't exist 15 years ago. So they're sort of catching up. You look at a place like I was in Brazil twice in the spring. I seem to be going there a lot more recently. Very different, very different. The people in Brazil strike me very similar to the people in India. Very, very excited about being an engineer. That's what they want to do with their lives. And they're just
awesome.
Yeah, it is.
Yeah.
It is. And a lot of companies are moving down there. Freescale's got a big operation in Sao Paulo, a bunch of other ones, because the Brazilian engineers are really, really good, really engaged, and much less expensive than Western engineers.
Yeah. There's an interesting trend which there's talk about this trend starting to ramp up, is that in particular Chinese companies are moving their R&D back to the US because they can't get enough talented people, not just, grunts who operate pick-and-place machines or something, but they need, talented design people. They can't get enough of them in a place like China.
Yeah, I think there's some truth to that.
What's your take on that, Jack? Do you have anything? Yeah?
I'm seeing that, but I refuse to call that a trend. I think that
one data point's not enough.
Well, no. Even if there's 100 data points, I think the truth. If you take, for example, China. I mean, again, a nation of vast resources, lots of smart people. If they want 100,000 universities, they'll make 100,000 universities. And a university by itself will not create talented people or innovative people. But it's part of the basic infrastructure that's required for an innovative climate to arise. And the Chinese are every bit as smart as we are. And as they build this infrastructure, I think that innovation will become, absolutely global. Absolutely global.
So we always talk about like the maker hacker kind of movement on here too.
Yeah.
What's been your take on that? Because I mean, we actually saw some news today that like even big companies are taking interest in it. Autodesk actually bought Instructables, which is a project-based site today, and
which we don't particularly like that much.
Well, that's just because we don't pay
we've
for
talked about it before because you have to pay to get all the information. You've got to join, pay a membership, and then they will give you the instructions to build something. And we don't. It goes against the regular open source, hacker ethos kind of thing.
Well, I'm going to challenge you on that, Dave. Number one. Okay, these are great questions. Before I hit the maker thing, open source, because something challenges open source, don't throw it out. Open source is just it's just one model.
I don't particularly like it.
Yeah, but I mean,
it doesn't mean it's not good. It doesn't mean there's not going to be a lot of people out there who will, and they'll find it useful. I personally just don't like their approach of doing it. But hey, they've made a lot of money, and they've made enough money for Autodesk to want to buy them. So
that's
good
great.
luck to them.
That's great, and I guess you work for free, huh?
Yeah. Well, no, and the other reason I don't like them is because a lot of the people who have put stuff on there they put stuff on there in good faith, thinking that they were giving it to people, and then they find that, people can't get my stuff. They've got to pay somebody else to get my stuff that I gave to the world for free. It's like, so... Yeah, and those people have actually complained to me about that. So,
that's crooked.
And I see their point of view. So.
Yeah, I agree. That's crooked, and there was a thing on Slashdot about that today. But
right.
Yeah, I mean, as far as the maker thing goes, I think that it's about freaking time. When I was a kid, I was into electronics from a very early age. Typical nerd. It took me a long time to figure out how to get a girlfriend. But I was into ham radio.
What the hell are they?
Trust me, you should definitely Google that. But I and all my friends were into ham radio because that was what the nerds did. That's how we learned electronics back then. We built radios and all this kind of stuff. Yeah. Most of us had no interest in talking on the radio, but we were building radios and doing stuff like that. And that's how generations got sucked into the electronics field. Well, ham radio is dying. And
Chris is taking his test soon, just so we
are
have that clear.
Yeah. Hey, yes, he is.
N3ALO.
N3A. I was going to ask that. So what is it again?
N3ALO.
ALO. All right.
The only time I use it is at C.
Okay, well that's okay though. I mean that's very useful actually.
But it was,
and it wasn't just the ham radio market that was dying either. If you asked me probably 8 to 10 years ago, I would have said hobby electronics was almost on its final deathbed.
It was
right.
But
it was terrible.
This maker thing is suddenly it's doing the most important thing that you can possibly do, which is getting kids excited about this stuff.
Yeah.
Whether it's electronics or biology or making cars or whatever they're doing. And, to me, one of the tests I use to trick people is I'll say things like, well, how does a TV work? And the answer I always get is, well, you press the on button. No.
The screen lights up, right? I mean, right. Then it tells me what to buy.
Well, everything else is magic. And as long as it's magic, that means that people are really enslaved by their technology. And I think curiosity and a desire to get some level of understanding of how things work is how we dominate nature. And that's what got me excited. The reason I'm an engineer is because I like to build stuff. It's not because of designing circuits or anything else. I like to build stuff, and part of building stuff is designing the circuits and writing the code and this kind of stuff. And that's what the maker
pointing at
thing
it
does.
And saying, "I did that. I made that." Right?
Yeah, and holding the soldering iron, and all that stuff. And I think the maker thing, and there's a lot of aspects to it, Arduino and all that, is fantastic. It's really wonderful. When my son was in high school, he was taking one of these practical classes, and the teacher gave him a problem. They were supposed to build a circuit, so if you pressed various combinations of buttons, different combination of lights would light up. And it was obvious what the teacher was looking for was a circuit with some diodes. And I said to him, Graham, if I were you, I'd throw a computer in there. I mean, this way it's easy to change stuff.
One of those little 8-bit micros that are dead, yeah.
Yeah, we were using a little Z-World board, and he did, and it pissed the teacher off. Because it wasn't the answer she wanted.
Oh, that's great.
That is brilliant. I love it.
So did you have a parent-teacher conference after that one, Jack?
Oh, yeah. And then I had to talk to the teacher about the classic case that you probably have heard of, where there's a test, and the physics professor on the test says, if you have a barometer, how do you measure how tall a building is? Mm-hmm. And one student gives the answer.
I know the answer to this one.
I throw it over the side and time how long before it hits the ground.
And time how long it takes. Yeah.
No, EMF. Okay, do it again. Well, I tie it to a string and lower it over the side, measure the length of the string. Oh! And this guy comes out with like 15 different answers.
I would give him an A straight away.
Yeah. But
thinking outside the box.
Yeah.
Brilliant.
Yeah. That's what engineering
They're
is.
the ones who turn into something, not the people who just learn things by route and, you know.
I'll give you another anecdote. A friend of mine was this is just 2 months ago, had a system with 45 little microcontrollers on it, all communicating with I2C, and there was some kind of a comm problem, and he couldn't figure it out. And I said, Brian, I've got this protocol analyzer on my scope that will watch I2C. We can figure this out in a heartbeat. So, we have a Thursday night group, which we've done for about 20 years. Every Thursday night, a bunch of us get together at a bar and drink beer, argue about politics and stuff. So I brought my fancy scope protocol analyzer there. He brought his embedded system there, power supplies. We set this up all over the various tables in the bar, and we're taking data.
Nice.
He figured out the problem, and this guy in the bar comes up to us and says, "You guys, what are you guys doing?" We tried to explain. He said, "You guys must make a lot of money, huh?" I'm thinking engineering was sort of the nerd career. These people are losers and stuff. But, in this country, once you become a senior engineer, you're making a 6-figure salary. Mm-hmm. That's the average family income in this country for the whole family, not just one earner. For the whole family, is $51,000.
See, it's not that great here in Australia, really.
Yep.
Yeah, you can earn 6 figures Australian.
Yeah.
But if you do earn 6 figures as just a regular design engineer, you're doing pretty well. So,
and that's not even real money, right? That's Australian dollars.
That's Australian dollars, which is worth more than the US, yes. I think it's $1.11 at the moment.
Getting out there.
It's so embarrassing.
Just want to boast there. Yeah. Mm-hmm. Oh, boy. So, yeah, I guess it is good money in US
It
terms.
is. It's a great profession.
But, it's once again, it's better than the average. Like the average wage in Australia, might be half that or something. So, yeah.
Right, and that's the way it is
it's
here.
It's definitely good, but it's not spectacular. And there's a cap. There's really a cap on that. Really, it's not like you're going to be able to earn $150,000 a year as an engineer here, or $200,000. That doesn't happen there. Doesn't matter how experienced you are. It tapers off. It's got that taper off effect.
And that's true here. I mean, virtually no one's going to make more than $120,000. But if you're doing something you love and you're making by comparison purposes, a ton of money, it's pretty hard to knock it.
Yeah.
So what about so we always hear these reports over and over again, we can't find enough engineers. What's your professional take on that? Like, because some sides we hear, well, that's actually corporations saying, we want cheaper engineers, and some say, no, this is actually real. We can't find engineers. So what's your experience with the embedded world, at least?
Every time I write about this, I get all kinds of angry email from people saying that it's the corporations are trying to drive salaries down, and the argument that people will make is if there is such a shortage, shouldn't salaries be going up because of the law of supply and demand? Well, the truth is salaries have gone up. We've been talking about how well an engineer can do compared to almost any other profession financially. My take on it is, I don't know if you saw last year, the IEEE was perfectly ecstatic that the year-to-year enrollments for EE students were down only 20% the best year in 10 years.
That's
really?
Horrible.
And what that says to me, and I've been following this for a while, there's this sort of negative bubble fewer and fewer people going into engineering. And that means fewer graduating, which means there are going to be fewer and fewer. We're getting older because there are fewer people, young people coming in, which means...
Yeah, but that's good for us, right?
It's great for us. We're here now. But it means that for companies, there will be an ever-increasing shortage, at least until this bubble corrects itself, if it does. Which means for anyone who is an engineer, I think it's a golden career. But I think that the engineer who thinks, as I used to think, that engineering was this beautiful thing, pure relationship with a soldering iron. No, I mean
we've talked about trade-offs before. Engineering is building something with stuff you can get.
But it's more than that.
Engineering is.
Today, engineering is this is a communications age, and today's engineer is going to be talking to engineers in India and China. If you can't communicate, if you can't write, at least technical writing, if you can't do even on like a 10-minute presentation somewhat coherently, it's not going to be. You're going to be that nerd that the classical nerd that everyone has made fun of. If you can master those things, and this is the advice I always give, especially young engineers, get halfway decent at technical writing. Doesn't mean you have to become a novelist or have character development or anything.
I'm putting my hand up here. Yes, I've written articles for 20 plus years, and I can't write for shit. I'm hopeless at it, but at least I can. I can actually string something together.
You can convey an idea, and that's what it's all about. Active voice. This does this. Do presentations. When I had my emulator company, I was terrified of standing before a crowd. And it became apparent to me that this is something I would have to master. And I worked really hard at learning how to not be terrified in front of a crowd. Now I enjoy it. It's something we need to be good at. And the engineer who is technically good and can communicate well is going to be golden for the future.
And I can vouch for Jack. I sat through 8 hours of listening to him talk about management, no less. So
oh my!
all told, I loved it. It was one of the best presentations I've ever been to, Jack.
Thank you. It wasn't the same sentence over and over.
It was not. It was not.
Okay.
I think it's like
an 8-hour presentation on 8 hours is the length of stuff I do. That sounds like one of my rants.
Hey,
I can rant on for 8 hours.
You do a whole project in 8 hours, right?
Yeah, man, that's a good point though. So Jack, I mean, speaking of writing and communication, I mean, you are obviously you've been writing for 20 years for various magazines now. I mean, how'd you get into that?
A bit over 20 years. I went to 12 years of Catholic education in my youth. And one of the things
my condolences.
Thank you. My knuckles still hurt. One of the things the nuns and Jesuits do is drive into you the whole English thing. You do an awful lot of writing, composition, and all. And I hated every minute of it. But what I found as I got older, I found myself enjoying the written communication more and more. Email, even. It's fun to structure a nice email. And I started, I've kept a journal, I don't know, for 40 years. And I've wound up digitizing that at some point, and then had ideas. I turned them into some articles, and they went over well. And Tyler Sperry, the first editor of Embedded Systems Programming, called me one day after I'd had a couple of articles run there and asked me to do a column. And that was like that was 1990, so that's been 21 years. I've been doing a monthly column in the printed edition, and for about the last 10 years, a weekly in the online edition. Yeah. And, the coolest thing about it, I mean, I enjoy the writing. I hate the deadline. But the coolest thing is the responses from the readers. I get so much email from people who are so smart and have such really interesting ideas that makes me question everything I know. There was when I was a young hippie freak, way back during the Vietnam era, there was a group called Firesign Theater, which was a comedy group that would riff on all the issues of the times. And one of their albums was called Everything You Know Is Wrong. And that's sort of the theme I've adopted in my life. That kids have taught me that everything I know is wrong, and the readers have taught me that everything I know is wrong. And one of the nice things is learning new things. It's correct a little bit of that wrongness.
Yep. Well, we should point out too that you have a weekly newsletter too, or not more of a at will newsletter, I guess.
Yeah, I do a newsletter, email newsletter that goes usually every 2 weeks, but like me, it goes on vacation during the summer.
That's a good thing. Yeah, that's one of my favorites too. I mean, that's a must read in my column. So.
Well, lately a lot of it's been stuff that people have sent in because they're doing so many interesting things, and they send in their ideas, and I reprint them, and I know it resonates with a lot of people. So it goes to about 25,000 people right now.
Whew.
Dang.
Excellent.
Isn't email wonderful,
Yeah.
It is. Do you
cool?
remember the days when you used to get letters? I can remember when I used to publish an article in the magazine, then I would get, and my address would be in there, and I'd actually get letters, hundreds of them, and I'd open, and I'd type up a reply and print it out. I actually started out on a real typewriter. Like an actual ribbon typewriter, typing people's replies. Or so occasionally I do a handwritten one. Mm-hmm. And geez, yes.
My daughter came to me a couple of weeks ago. She had to mail something to someone for some reason. And she said, "Do I need a stamp or something to do this?"
Oh no! Fail. Modern generation fail.
Oh, that's fun though.
When I was a student at the University of Maryland 1,000 years ago, we had a big mainframe, a big UNIVAC mainframe, and we had email. This is 1971, and
wow.
The way email worked was you type your email in or use a punch card deck to put it into the computer, and then at night, these mainframes would call each other up on 300 baud modems and exchange the stuff all over the country. It was awful, but it seemed great at the time.
I was going to say, I bet at the time you guys are so excited.
Yeah, it was wonderful.
It's like magic.
It really was.
But I wouldn't give up email and the information revolution for anything.
It's
just awesome.
It's fantastic. It really is.
It's opened up a whole new world, especially on the design side. I've talked about it before. The amount back before the internet. That was before you were around, Chris. You had to actually do engineering without the internet.
Hey,
young whippersnapper, you.
I'm outnumbered.
You could only design stuff based on what you had in your data book library, in your personal library.
Yeah.
That's the or some ad in a magazine for a new chip. That's all you had.
Well, Dave,
nowadays you can.
I don't know if it was like this in Australia, but they would hold at the distributors who are long gone now. Once or twice a year, there'd be this come and get data books things. And we'd drive to them, and we'd fill the car with data books. Remember
you'd fill your boot.
The TTL, the TI's TTL handbook, the yellow.
Yep.
Oh, my God.
Yes, I've still got one.
Yeah.
Right next to me. It's half a meter away from me. Yep.
Is that a foot and a half? I don't know.
Yes.
But it was.
Jack's back on my side.
Bloody feet. Yanks.
Yeah. But it was all about the data books, and every year they change. I can't imagine what the printing costs. This is before PDFs and stuff like
phenomenal.
that.
And they're all 1,000, 2,000 pages, these data books. Oh, massive.
But last year I was involved with a part. One chip, the data book was 5,000 pages and was woefully incomplete for one IC.
That's, yeah.
The data sheet?
The data sheet was 5,000 pages and woefully incomplete. You had to talk to the
5,000, you can't blame them. There's probably
Come on,
1%
name and
failure.
shame. Name and shame the chip.
Texas Instruments OMAP.
Oh, no.
Oh, yes.
And they crank out a lot of those, too.
They're very popular, though.
They're in the mobile phones.
Massively
they're
popular,
fantastic
those
parts.
things.
They're just very complex.
Oh, yeah.
Yeah. Man, 5,000 pages.
They're the ones with the RAM piggybacked on top, right? They've got the DRAM, the silicon. It's physically piggybacked on top of the silicon of the processor, and it's all packaged up in one. That's how they get the large RAM.
I bet there's
the large RAM density in there.
I didn't count, but I bet you there's on the order of 5,000 control registers inside of it.
Oh, my God.
Oh, really?
Is that cool?
Yeah.
That's an amazing part.
Yeah.
But it does everything. I mean, it's amazing what they do.
Oh, yeah.
And,
I know we talked to Jason about like BeagleBoard stuff, and it's almost like you need that to just start somewhere, because if you're starting from a 5,000 page data sheet,
it's insane.
Throw your hands up and walk away and go get a law degree,
Well, what everyone,
easier.
the IC vendors are all telling me that what they're having to do today is provide a lot of the whole solution to their customers, the hardware and the software, because the customers don't have the time to write the software or to even understand these parts. So they have to supply that, but they're having trouble with their own.
They have to supply
management.
the apps, and everyone works from apps. Like you know, a lot of people, smart engineers will choose they won't be locked into one device. They'll choose the device which already has the app closest to what they want.
Sure.
You know, because that will save you a crap load of time and money and effort. And you know, if they've got an example app that does, you know, tweeting via Ethernet or something like that, which is exactly what you need, you're going to go for that chip.
Yeah. I mean,
even though you're a PIC fanboy or an AVR fanboy or something like that, you know, the smart ones will change devices, bang, like that.
Well, it's all about the Benjamins, you know. How can you save the most money, get the thing to market fastest?
Right. Benjamin. See, I don't...
that doesn't translate for Dave.
No, it does. I'm Americanized enough to
paper.
know that you have Benjamin Franklin. Is it on your $100 bill?
That's right,
you're good. You're good.
Yep.
Oh, I'm good. There you go. I watch too much American TV, obviously.
Well, one thing that I also try to drive into engineers' heads is it really is all about the Benjamins. We're paid to accomplish a business goal. It's all a business endeavor, and we've got to help the company make a profit. And there are a lot, you know, we do our cool stuff, but ultimately, the only reason we're getting a paycheck is to design a product that helps the company make money. And it's very easy for us to get pure and innocent and, yes, but the correct solution is this. And but no, that's not really true.
Right.
There are a lot of other really important issues involved.
There are many correct solutions.
Yes, there truly are. It's all a trade-off, and a trade-off is far more than just engineering trade-offs.
Yeah.
And that's our 1 hour. That's our amp hour, folks.
That flew by.
That
flew by, Jack.
That did. That was fun.
How was that? That was painless, right?
Painless. That's the best you can say.
Well, I'll accept the audio setup at the beginning.
Yeah.
Yeah, and hopefully it's recorded, because you're recording with Vista.
I'm recording with Vista, and I will make every effort to send this to you, Chris. It may be too big to email, but if so, I'll get you an FTP.
Have our ways.
Oh, we've got ways around that. We have ways and means.
Okay.
But make sure you don't hit cancel. Make sure you hit save straight away after this. Otherwise,
too late.
Otherwise, we might be stuck with the Skype recording. Chris is apparently trying to attempt.
Yep.
Oh, boy.
As a backup. Oh. Anyway.
So Jack, any final words before we close down the amp hour?
Well, sure. If I were giving final words, you know, as a certified old fart to engineers today, I would say embrace the field. Never stop learning. Things are changing so fast, and yet my data suggests that most of us don't read much and don't get many technical magazines. If you're not getting at least 10, 12 technical magazines a month, you're not connected with this field. And one thing I always say to engineers is save money. Bad things happen to good people.
That's one of my Dave's top 5 tips.
Is it?
I call it screw you money. Watch, search YouTube for Dave's the top 5 engineering tips or something. I don't. That's one of them. Is
awesome.
Is have enough screw you money. I call it.
Yes.
So that you can just tell your employer to. You know,
yes.
Employ off.
Stick it.
Or oftentimes,
I've got money. It'll tide me over until I find another job. Thank you very much. I'm not taking your Dilbert rubbish.
Or for reasons of not your own fault, your employer may tell you that as well.
Yeah.
You know?
In today's tough climate,
money gives you options.
I'm always of the opinion that if you're good enough, there's always a job.
Yes, I think that's really true. But be prepared. You know. Complicated, difficult things happen. You know, people get sick.
Shit happens.
You know, shit happens.
Yeah. Exactly.
And I think that the one thing that we're missing here, guys, is that at some point we should get together for a beer.
That might be quite a hike.
That might be a bit tough for me.
Well,
and the fact that I don't drink, but
that's
another
tough.
stereotypical
root beer for Dave.
A double stereo. A, I'm an engineer, and B, I'm Australian. I don't drink. What?
I didn't think Australians were like that. Have they haven't kicked you out yet, huh? I was talking to a buddy he was going into Australia, and the customs or immigration said, "Do you have any criminal record?" And he quickly snapped back, "Oh, do you still need one?"
Oh, well done! Wow, I'll pay that.
Well, I think
How was that received?
I don't remember what the response was.
never heard from him again. I don't know why.
Right.
My experience in Australia is that people have a great sense of humor, and I'm sure that there's a laugh that came out of that.
You couldn't help
that's
but.
great.
I love it.
We might have to play the Dave snuck in the Australian some Australian pride songs when I'm not editing, so we might have to sneak one in just to make it feel better at the end of the show here.
Good. One of my favorite countries.
Awesome.
You guys are so much fun.
Yep.
Well, thank you very much, Jack. It's been a pleasure.
Well,
yeah.
Thank you, guys. I really had a good time.
Yeah, we hope to have you on again soon.
Excellent.
Sounds like a plan, man.
Absolutely.
All right.
Been a good show. Thank you very much, everyone.
Yeah, we'll talk to you guys next week.
See ya.
Bye-bye.
Embedded Elchee Epexegesis. Oh my god. What the hell is that word?